Lesson: Properties of operations and equations. Politics is for the present, but an equation is for eternity. Albert Einstein. The commutative property manifests itself in addition and multiplication differently. A binary operation is commutative if changing the order of the operands does not change the result. The sequence of the operands is changed. A plus B is equal to B plus A is the commutative property of addition. The first term of the left side of the equality equals the second term of the right side of the equality. The second term of the left side of the equality equals the first term of the right side of the equality. The sequence of the terms is changed. As for multiplication, A times B equals B times A. The first factor of the product of the left side of the equality equals the second factor of the product of the right side of the equality. The second factor of the product of the left side of the equality equals the first factor of the product on the right side of the equality. In this case, both sides of the equality are sums that have three terms. The first terms on both sides of the equality are equal, 18 and 18. The second term on the left side of the equality is 2 times the quantity x minus 7, and it equals the third term on the right side of the equality. Likewise, the third term on the left side of the equality, negative 4 times the quantity 2x negative 3, equals the second term on the right side of the equality. The sequence of the terms is changed, and the equality above illustrates an example of the commutative property of addition. Now for this equality, both sides are sums that have three terms. The first two terms are yet again equal, 18 and 18. The second two terms on both sides of the equality are also equal, 2 times x negative 7. These third terms are both products and have the first two factors equal, negative 4 and negative 4. The first term of the parentheses on the left side of the equality equals the second term of the parentheses on the right side of the equality. The second term of the parenthesis on the left side of the equality equals the first term of the parenthesis on the right side of the equality, negative 3. The sequence of the terms is changed, but the equality above illustrates an example of the commutative property of addition. This is not an example of the commutative property. The third term of both sides of the equality are equal, negative 4 times the quantity 2x negative 3. The first term of the equality, 18, equals the first factor of the second term of the right side of the equality. The first factor of the second term of the left side of the equality equals the first term of the right side of the equality. If the sequence of a term and a factor is changed, the two expressions are not equal. Important: not all operations are commutative. Operations such as function composition and matrix multiplication are not generally commutative. So let's move on to the associative property. It is a property in which rearranging the parentheses in an expression will not change the result. The order in which the operations are performed does not matter as long as the sequence of the operands is not changed. So in this addition example here, the sequence of the terms is not changed, just the order. So we have A plus the quantity of B plus C equal to the quantity A plus B plus C. In this case, the terms of the sum are grouped differently, but the position of the parentheses is also changed. The sequence of terms is not. So for example, 2 plus 34,567 plus 998. The commutative and associative properties of addition allow us to find the answer of the sum using some easy mental math. So let's apply the commutative property of addition and change the sequence of the first and second terms, obtaining 34,567 plus 2 plus 998. Applying the associative property of addition, grouping the second and third terms of this sum, and performing calculations, 34,567 plus 1,000 equals 35,567. As for multiplication, the factors of the product are grouped differently. The position of the parentheses in the product is changed, but the sequence of terms is not. So we have A times the quantity B times C equals the quantity A times B, everything times C. An example of this being 4 times 4,981 times 25. The commutative and associative properties of multiplication allow computing using mental math. So let's apply the commutative property of multiplication. Changing the sequence of the first and second factor, we obtain 4,981 times 4 times 25. Grouping the second and third factor of the product and performing calculations, this is equal to 4,981 times 100, which equals 498,100. As for the distributive property of multiplication over addition, we can represent that as A times the quantity of B plus C is equal to AB plus AC. To multiply a number by a sum, multiply the number by each term of the sum. Important: to multiply a number by a product, multiply the number only by one of the factors of the product. Example: 4 times the quantity negative 2x plus 5 times the quantity 3a minus 2. Apply the associative property of multiplication. So we group the first and second factors of the product, which equals negative 8x, 4 times negative 2x, plus 20, 5 times 4, multiplied by 3a minus 2. Or apply the commutative property of multiplication. So that's equal to the quantity negative 2x plus 5 times 4 times the quantity 3a minus 2. Applying the associative property of multiplication and grouping the second and third factors of the product, we can apply the distributive property of multiplication over addition, which equals the quantity negative 2x plus 5 times the quantity 12a minus 8. 4 times the quantity negative 2x plus 5 times the quantity 3a minus 2 is equal to the quantity negative 8x plus 20 times the quantity 12a minus 8. It is incorrect to distribute 4 to both factors. So these two expressions are not equal. It was a trick. The right side distributed 4 to both factors when they should have only done 1. Now we have the identity property. That is, for addition, a plus 0 equals a. 0 added to any number equals that number. And 0 is thus called the neutral element of addition. As for multiplication, 1 multiplied by any number equals that number. 1 is called the neutral element of multiplication. Important. The neutral element of a set of numbers under an operation keeps the identity of the number. Moving on to the inverse property of addition, the sum of a number, a, and its additive inverse, opposite, negative a, is equal to the neutral element of addition, 0. The additive inverse of a number brings the number back to the neutral element of addition. So if we think of 0 as the neutral, we go away from it a steps and return to it by negative a steps. As for multiplication, the product of a number, a, and its multiplicative inverse, known as the reciprocal, represented as 1 over a, is equal to the neutral element of multiplication, 1. The multiplicative inverse of a number brings the number back to the neutral element of multiplication. We move away from 1 by multiplying by a number a, and then return to it by multiplying by the reciprocal, 1 over a. So the two operations, addition and multiplication, have 5 different properties as we talked so far: commutative, associative, distributive, identity, and inverse. And all of these are very important for questions that you will be solving. So let's get into some of those questions. Identify the property and the operation. Question 1. 12 plus x plus 15 equals x plus 12 plus 15. Each side of the equality is a sum of 3 terms. The first term, 12, becomes the second term. The second term, x, becomes the first term. The sequence of the 2 terms in the sum is changed, which is the commutative property of addition. Question 2. 5 times the quantity of 3 plus 0 equals 5 times 3. Each side of this equality is a product of 2 factors, where the first factor in each product is the same. The second factor of the left side is 3 plus 0, and the second factor of the right side is 3. 3 plus 0 equals 3 because of the identity property of addition. Question 3. 5 times the quantity 3 plus 0 equals the quantity 3 plus 0 times 5. Each side of the equality here is a product of 2 factors. The first factor of the left side of the equality, which is 5, becomes the second factor of the equality. The second factor of the left side of the equality, or the quantity 3 plus 0, becomes the first factor of the equality on the left side. The sequence of the factors is changed, and thus this is the commutative property of multiplication. Question 4. 5 times the quantity 3x plus 7 equals 5 times 3x plus 5 times 7. The left side of the equality is a product of 2 factors. Its second factor is a sum. Now the right side of the equality is a sum of two terms. The first factor, 5, multiplied every term of the parentheses, which means that we're observing the distributive property of multiplication over addition. Question 5. 2 times the quantity of 3x plus 4 plus 7 equals 7 plus 2 times the quantity 3x plus 4. Both sides of the equality are sums of two terms, but the sequence of the terms is changed. The 2 times the quantity 3x plus 4 is the first term of the left side, which becomes the second term, and the second term of the left side becomes the first term of the right. This is thus the commutative property of addition. Question 6. The quantity of 2 times the quantity 3x plus 4, everything times 7, is equal to 2 times the quantity of the quantity 3x plus 4 times 7. Now in this case, both sides of the equality are products of 3 factors. The sequence of the factors is not changed, but the left side of the equality groups the first and second factor, 2 times the quantity 3x plus 4. The right side of the equality groups the second and third factor, the quantity 3x plus 4 times 7, which means that we went through the associative property of multiplication. Now, a new kind of exercise. Let's use the indicated properties to complete the blanks. Question 7. 12 plus x, and we know we utilize the commutative property of addition. The commutative property changes the sequence of the terms such that the second term becomes the first term and the first term becomes the second term. So 12 plus x is equal to x plus 12. Question 8. The quantity 2 times 3x, everything multiplied by 5, utilizing the associative property of multiplication. So the associative property does not change the sequence of the factors, but rather the grouping. The left side of the equality has the first and second factor grouped. So now we can group the second and third factor. This then equals 2 times the quantity 3x times 5. Negative 13 equals blank, the identity property of multiplication. The neutral element 1 of multiplication does not change the identity of the number, so negative 13 equals negative 13 times 1. Now, negative 13 blank using the inverse property of addition. We add 13 because the additive inverse opposite brings the number negative 13 back to the neutral element of addition, 0. Now, utilizing negative 13 and the inverse property of multiplication, we should multiply by the multiplicative inverse, or the reciprocal of a number, which brings the number back to the neutral element of multiplication, 1. So the reciprocal of negative 13 is negative 1 over 13, and the product of those two numbers equals 1. Negative 3 times the quantity 2x minus 5 times 4 equals what, given the commutative property of multiplication? The left side of the equality is a product of 3 factors. The commutative property changes the sequence of these factors. Keep the first factor, change the third factor, so we kept the negative 3, change the third factor by making it the second factor, so times 4. And since we interchanged it with the second factor comes last, the quantity 2x minus 4. The distributive property of multiplication over addition. multiply the first factor by each term of the second factor, which is a sum. So we're going to multiply negative 3 by the quantity 2x minus 5, obtaining the quantity negative 6x plus 15 times 4. Or we could keep the first factor the same, negative 3, and multiply the last factor by each term of the second factor. So 2x times 4 is 8x minus 20, negative 5 times 4. Now here we have negative 4 and we want to use the inverse property of addition, which is the additive inverse. The additive inverse, or the opposite, brings the number back to the neutral element of addition, 0. So we add a 4 and we obtain 0. Now for the identity property of multiplication, 1 under multiplication does not change the identity of the number. Negative 4 times 1 equals negative 4. The property hasn't changed. Now, another property of equality we haven't discussed yet is the reflexive property, which is quite simple. A equals A. All numbers or expressions equal themselves. For example, x plus 5 equals x plus 5. Then we have symmetric. If A equals B, then B equals A. The sides of an equality can be changed. For example, 2 equals 9 plus 5x is equivalent to saying 9 plus 5x equals 2. Third, we have the transitive property, which states that if A equals B and B equals C, then A equals C. For example, 3 equals A plus 5B. 3 also equals 2B minus 5. Therefore, A plus 5B equals 2B minus 5. Another example would be that if y plus 3 equals x plus 5, and 2y minus 1 also equals x plus 5, thus y plus 3 equals 2y minus 1. Moving on to the addition property, if a number is added on both sides of an equation, the equations are equivalent. So if A equals B, then A plus C equals B plus C. For example, x minus 7 equals 3 is equivalent to saying x negative 7 positive 7 equals 3 positive 7, which is equivalent to x equals 10. Next, we have the subtraction property, which is quite similar. If a number is subtracted from both sides of an equation, the equations are equivalent. If A equals B, then A minus C equals B minus C. Then we have a multiplication property. If a non-zero number multiplies both sides of an equation, the equations are equivalent. If A equals B, then AC equals BC. For example, x plus 3, everything over 5, equals 2. Multiply both sides of the equation by 5, we get the equivalent statement, x plus 3 equals 2 times 5, which equals 10. Similarly, we have division. So if a non-zero number divides both sides of an equation, the equations are equivalent, such that if A equals B, then A divided by C equals B divided by C. For example, 2x equals 18, divide both sides by 2, equivalent to x equals 9. And those are all the properties of equality lined up together. So now that we've learned those, let's use the indicated property to write an equivalent statement. 5 equals x plus 4, using the symmetric property of equations, is equivalent to x plus 4 equals 5. 5 equals 10 times the quantity x plus 4, using the division property of equations. Now to engage this property, let's divide both sides of the equation by 5, which is equivalent to 1 equals 2 times the quantity x plus 4. Now we have two equations here. 5 equals 10 times the quantity x plus 4, and 5 equals 2 times the quantity y minus x. And let's use the transitive property of equations. It looks like both of these equations equal the same number or expression. Thus, 10 times the quantity x plus 4 is equal to 2 times the quantity y minus x. Now let's do that again. Run it back on the transitive property of equations. Y equals 10 times the quantity x plus 4, and y equals 15. Thus, 10 times the quantity x plus 4 equals 15. Now, 5 minus 20x equals 10 times the quantity x plus 4. Let's utilize the division property of equations and divide both sides of this equation by negative 5. Equivalent to 1 minus 4x equals 2 times the quantity x plus 4. Find the additive inverse of each number. 14. The additive inverse of 14 is negative 14. The additive inverse is the same as the opposite. The number and its additive inverse differ only by their signs. Negative 24. The additive inverse of negative 24 is 24. Now we're changing it up. Find the multiplicative inverse of each number. The multiplicative inverse of negative 24 is negative 1 over 24. A number and its multiplicative inverse have the same sign, and the multiplicative inverse of a number is the same as the reciprocal, 1 over that number. So let's do it again. Negative 3 over 25. The multiplicative inverse of that is negative 25 over 3. Name or determine the property of each operation or each equation that has been illustrated below. 12 negative 20 equals negative 20 plus 12. This is the commutative property of addition because we've swapped the position of the first and second terms in our equality. 12 negative 20 times 30 equals 12 negative 30 times 20. This is the commutative property of multiplication because the first term has stayed the same, but we have swapped the positions of the multiplication in the second term.